Let us continue with the 3 marks question. Question number 54. Prove that root 2 is an irrational number. Here, first we have to assume root 2 is a rational number. If it is a rational number, we can write it as root 2 is equal to a by b. So root 2 is equal to a by b. It will be written in the form of rational number. So 2 is equal to a square divided by b square. If you cross multiply, you will get 2b square is equal to a square. A square is divisible by 2. Then a is also divisible by 2. A have 2 as a common factor. We can write it up as a is equal to 2k. Then by squaring both the side, you can write a square is equal to 4k square. 2b square is equal to 4k square. B square is equal to 2k square. Therefore, b square is divisible by 2. Then b is also divisible by 2. B and 2 as a common factor. A and b have at least 2 as a common factor. But this contradicts the fact that a and b are co-prime. Therefore, this contradiction has arisen because of our incorrect assumption. Therefore, root 2 is a irrational number. So this is regarding the question number 54. So here we have to follow the steps one by one. We have to consider root 2 is a rational number. Then if it is a rational number, we have to write root 2 is equal to a by b. Then by squaring, you can remove the square root. Then 2b square is equal to a square and divide, and we have to consider one common factor as a k. Then square both the side. Then you can tell that our contradiction is wrong. Therefore, our statement is incorrect. Therefore, root 2 is a rational number. So this is regarding question number 54. Question number 55. So in the question number 55, again same method you have to do for root 3. So take it as homework. It is similar to question number 54. Same reference only we have to do for here question number 55. Let us continue with the next problem. So take this 55 as a homework. Next question. Prove that root 5 is an irrational number. Again, same method only you have to use. Only the number is different, but the method is same. Root 5 is a rational number. Root 5 is equal to a by b. Then square root should be removed. Then take 5b square is equal to a square. Then take common factor a is equal to 5k. Then by squaring both the side, you can write b square is equal to 5k square. Therefore, it is divisible by 5. Then a and b is the least common factor. Therefore, our assumption is wrong. Therefore, root 5 is a irrational number. Same method you have to follow here in question number 54, 55 and 56. Only the number is different. Root 2, root 3 and root 5. It is very important for your examination. So, practice this problem. Question number 57. In question number 57, find the HCF and LCM of these numbers 5, 10 and 92 by method of prime factorization method and verify that LCM into HCF is equal to the product of the numbers. So it is asked already in the state level question paper in the 2024. It is very simple problem. Here you have to do the prime factorization method for 510 and 92 separately. After that, by using the formula LCM into HCF is equal to the product of the numbers, you can find the value of the number here. So here you can see here 2 2s are 5, 2 5s are 10. So 0 you can write here. So 3 85 is a 5 70 is a 17 ones are. So you will get the factors of 5 10 as 2 into 3 into 5 into 17. Then here in the 92, 2 4s are 8, 2 6s are 12, 2 2s are 4, 2 3s are 6 and 23 ones are 23. You can write 92 is equal to 2 into 23 as a factor. Then you have to find the HCF. HCF means the number should be there in common in the both the numbers, that is 2. And the case of in LCM, you should write all the factors, that is 2 square, 3 into 5 into 17 into 23. So this is, if you multiply, you will get LCM is equal to 23,460. By using the formula L sheet HCM into LCF, HCF into LCM is equal to A into B. If you multiply, you will get the product as 46,920 as in the similar condition. So this is the product of the integers here. So this is regarding question number 57. So do the prime factorization method, then find the HCM and LCM and use the formula. So this is regarding question number 57. Next question, it is similar to the past question. So take it as homework. So it is similar to 57 only. Same thing you have to do for 336 and for 54 you have to do the prime fraction method. Then find the LCM and HCF and the product of the integer. It is similar to question number 57. So refer and solve this problem and comment the answer in the video. Next question. Question number 56. Again, it is similar to that only. 26 and 91 is given. Do the prime factorization method and find the LCM into HCF and the product of the number. Again, by using the prime factorization method, you will get 2 into 13 as 26 factors and 13 into 7 as the 91 factor. HCF is 13 here. LCM is 182. By using the formula, HCF is 13 into 182 LCM is equal to A into B is 26 into 91. You will get 2366 as the answer. Same only you have to do. It is similar. 57, 58, 59 is same type of question. First you have to solve the two number in the prime factorization method. After that HCM and LCF you have to find out. Then use this formula. So simple. It is very important for 3 marks question in this chapter. Let us shift with the next problem. Question number 60. Find the HCF of 135 and 75 by prime fraction method and then find the LCM of HCF 135 into 75 and 20. So here again you have to do the prime factorization method for the 3 number. That is 135, 75 and one more is 20. So here in the 59th, 58th, 57th question we took only 2 numbers. Here we have 3 numbers. 135, 75 and 20. So here you have to solve by using prime factorization method. After that you have to find the LCM and HCF. Here you can see the prime factors of 135 is 3 into 3 into 3 into 5 and here in 75 3 into 5 into 5 in 20 2 into 2 into 5 is the factors. Then HCF means similar number. Here only 5 and 3 is common. Sorry, 5 and here also 5 is there. Here also 5 is there. Here also 5 is there. So I can write 15 as the LCM here, and in the case of HCF and in the case of LCM 2 into 2 into 5 into 3 into 5, that is 60. And by using the formula you can find the value. So H into L is equal to A into B. So this is the formula. So remember this formula. This is very important. Okay. So this is regarding question number 60. This question is already asked in your state level preparatory. So practice properly this problem. Let us shoot with the next problem. Question number 61. Find the LCM and HCF of 12 and 15 and 21 by prime fraction method. Again 12, 21 and 15. So 3 numbers are given here. Do the prime factorization method, you will get the factors, and HCF you will get 3, LCM you will get 420. So very simple problem it is. So question number 62. Find the LCM and HCF of 6, 72 and 120 by prime factorization method. Again same method. Use the prime factorization method, get the factors and write the HCF and LCM. Here HCF is 6 and in the case of LCM it is 360. Next question. Question number 63. An army contingent of 660 members is to march behind an army band of 32 members in the parade. The two groups are to march in the same number of columns. What is the maximum number of the columns in which they can march? Also find the numbers of rows of each item. So here in the question 660 members are there in the march and also the 32 members are in the parade. We have to make it in the groups in the column. Also we have to find the number of the rows of the each time. So again we have to use the prime factorization method. By using prime factorization method we have to get the factors here. So we have here two numbers, that is 616 and 32. Let us consider as A and B. So by using prime factorization method here 2 3s are 6, so 16 is there, so take it 0, 2 8s are 16, then 2 1s are 2, 1 will be shifted here, so 2 5s are 10, 2 4s are 8, then 2 7s are 14, 2 7s are 14, 7 11s are 77, 11 1s are 1. So here are the factors are there. 616 can be written as 2 cube into 7 into 11. Next number is given here The first one is 616. The factors we are already got. Next one is 32. Again, 2 ones are 2, 2 sixes are 12, 2 eights are 16, 2 fours are 8, 2 twos are 4, 2 ones are 2. So the factors are 2 raised to 5. So HCF of 616 and 32 given as 8. So maximum number of the column is nothing but 8 only. So this is the last problem of this LBA series. If you understood my video, please don't forget to comment, like and subscribe my YouTube channel, and also share to your 10th standard friends. They can also take the usage of this LBA solution. So thank you for watching my video. Don't forget to like, comment and subscribe my YouTube channel.